Hey, what's going on, folks? It's Mike here, and welcome back to the Deep Programming Language series. In today's episode, we're going to be talking about hiding or visibility, that is, things like public, protected, and private, which might be familiar concepts. So we're going to talk about them as they're related to classes and structs. Now, in D, there is also package and export, which we're going to talk about and are a little bit more relevant once we talk about modules and packages in the D ecosystem. So stay tuned, stay subscribed for those. We will get to those shortly in this series. So those are some upcoming lessons here. But since we've been talking about classes, we do need to talk a little bit about information, hiding or encapsulation, which are sort of related ideas about how we access or allow access to the classes that we build. And there's some different defaults in the D programming language that might be new if you're coming from, say, C++ or Java or other object-oriented programming languages. So with that, let's go ahead and dive in on the D programming language website. Now, what I've got here, I'm going to go to the documentation here, the language reference. We're going to end up in this attributes section, so I'm just going to open it up here. But I want to go to classes here. And again, everything that we talk about is mostly applicable to structs. Structs don't have inheritance, remember, so, in some context, we only care about private and public with structs, but we'll get into that. But let's just go ahead and dive into classes here. And if I scroll down here just a little bit here, under access control, which I don't believe, I guess it's the very first bullet here. That's what I'm looking for. I'm not actually looking for, there is something about accessing hidden fields here. That's not the type of hiding we're talking about. That is related to something important that we covered in some previous lessons, meaning the V table or the virtual table. And later we'll learn about monitors and locks and synchronized. So let's just anyway stick to access control here, which is again going to take us to this attributes page. And we care about these visibility attributes here. So export and package, we're going to talk about a little bit more in the future, but private, protected, and public, we want to talk about now here. So let's go ahead and, again, we can see these are the various attributes that we can put on things like member variables or member functions, or even functions or things in the D language as well. And you can see here, I mean, just looking at some of the other attributes, again, we're going to talk about export later, but, these could be on just like global variables or, shared variables or on functions and so on. So we get quite a bit of granularity in the D programming language here. So anyways, let's look at private, protected, and public here. Let me try to minimize this screen here just a little bit here. And just, again, talk about this idea here. So just to start here, let's go ahead and get the word here, encapsulation here. Now, this is one of those words that you learn about if you've picked up a book on like object-oriented programming. It's one of the tenets that people, core pillars, sometimes they say, in object programming, object-oriented programming languages. And maybe I've even mentioned that on some of my other series, things like, abstraction, encapsulation, information hiding, message passing, all these sort of things here. But I mean, encapsulation's important in any sort of programming language. It's what information do you expose? So we often just think about this as visibility. Information hiding, again, is a related idea here. Information hiding. And, sometimes this means things like using private, protected, and public. Sometimes this means hiding things behind a void pointer or something, so you don't know the type, for instance, and that's sort of hidden, or you're hiding information behind some implementation, like the pimple pattern, which we've covered in my C++ series, but we'll have to cover later in the D programming language series because it's one of my favorites. But the basic way to think about this is if I have some class here, and let's just draw, as a box here, and we can, do class, C or whatever. And I've got some information here. And again, we can kind of just delineate here. Let's say I've got something like a value here. That's one of the fields. We don't really care about the type here. And then let's say I have something else, here like a secret. Okay. And some of this information I want to expose, some of it I don't want to, right? Maybe this is a, secret password or something. So I kind of want to keep, the things walled in here with an extra layer of security, right? To the best of our ability. So we'd say that this might be sort of private. So that means, again, that I can use it within this world here, right? Within this class here, but it can't escape outside here, okay? Whereas value here, I might make public, okay? Public. and it is available to the outside world, right? So I can actually just explicitly call on some instance of a class here, c dot, value equals, whatever. Okay, so that's the basic idea. That's what these attributes do. Now, again, making something public and private, it still belongs to the class. It's still part of the overall, size of this class, right? If these are both integers, value and secret, then my class is at least going to be 8 bytes, right? 4 bytes for each integer. And remember, again, in the D programming language, an integer is well defined as 4 bytes. Again, if you're just hopping into the series. So anyways, it's still part of the class, still part of the allocation. It's just that the outside world can't access these values here. And again, that's important because sometimes you learn when you're programming to write a helper function, or you just need some internal bookkeeping within your class, for instance. Okay, so I think you kind of get the idea here. Let's go ahead and kind of look at these here. I'll leave the help page up here, and we'll just kind of play around with these here. So let's go ahead and maybe work with a class here, and I'm just going to call it. Let's just call it example for now, for lack of a better term here. Or actually, no. Let's try to make it a little bit more real here. Let's make it like spaceship or something like this here. And again, let's instantiate one instance of our spaceship. Since it's a class, I need to allocate it with new, as always. And then we can start making use of it. Okay, so let's go ahead and see what's going on here. And let's just kind of go... I'm going to go kind of in reverse order here. So public attribute. So public means that any code within the executable can see the member. It is the default visibility attribute. Okay, so let's go ahead and give our spaceship maybe speed, something like that. And again, I like to prefix my member variables with M. That's just kind of a stylistic thing that I've done here. And by default, everything is public. Okay, this is different than other languages, like C++, for instance. So this is just a thing for you to pay attention to, because in C++, right, a class, things are private by default, and a struct, they're public by default. D just said, we're doing away with that. Everything's public, right? And then you decide. A little bit of a controversial. Some folks don't like that. I actually like this decision. I want my code to be easy to write, and then I can sort of more conservatively hide things. That's actually easier for me to do in this context, but again, maybe it's something I've gotten used to, just something that you'll have to get used to in D. So again, the default visibility attribute is public, so I don't need to do anything special here. But let's just go ahead and give ourselves some other variables here, like maybe there's a secret access code to unlock some sort of spaceship here, and I want this to be private, right? So I could do something like this here. So let's just go ahead and see what happens here. So again, symbols with private visibility can only be accessed from within the same, ooh, this is interesting here. I was expecting same class, but it's actually same module, okay? So that's kind of interesting here, that, well, let's just see what I can do here. s.mSpeed equals, 7. s.m access code equals 1 2 3 4. Let's just go ahead and pick something like that sort of randomly, and will this run here? And depending on the programming language that you're used to working in, your answer might be yes or no, and the answer is this does work. This compiles, this runs fine here. I guess we should like print out our spaceship here. Let's just write out our class here. So since it's a class, this is going to print out main.spaceship. If we change this to a struct, here, let's change this to a struct, and then we've got to make this a pointer since this is a heap allocation, or just use auto. This will write out, I guess it's writing out the address now. My fault here. Let's write it out and dereference it. And then it'll give us the fields here. Okay, so this works here. And again, what I'm demonstrating, one, we have these access modifiers for structs and classes just the same here. I'm going to undo that. I just wanted to show that at some point. But again, what's really interesting is that the module, so every file in D is effectively a module, right? I've been a little bit lazy about it because we haven't learned about module yet. And by default, that means that a module has just been named whatever our D file is. But private variables are accessible within this entire code here, okay? So let's just go ahead and make a little note about that here. So note, and let's see, let's go ahead and, sometimes I like to just use my indentation here. Private is available per module, okay? Private visibility. And in a way, this kind of makes sense. I think part of the design motivating this was because if I want to write a helper function here, like void print spaceship here, spaceship, and we want to pass in a spaceship here, like s, and then I could write out s.mSpeed and write out s.mAccessCode. Okay, so now I can write out my spaceship, right? This is going to, here, let's actually call our little helper function here. And do print spaceship s. Okay, passing in the reference type here. And we might actually want to do something like make this const, let's see, something like that. Anyways, now I can print out the spaceship. And this is kind of nice. I mean, the problem that this sort of fixes, and again, why I believe this is, again, this is my opinion. This is just one of those programming language design things that you have to decide, you know, what the defaults are. I'm okay with this because what this means is I don't have to use like friend functions, which were the thing in C++. I just have everything that's related here, okay? So, okay, so you might not like this overall, or you might say, hey, Mike, remember that diagram you showed with encapsulation here? And you're talking about this idea. How do we actually encapsulate this thing now? Okay, well, let me show you here. For this, I'm going to make our screen a little bit bigger here. And, oops, let's make sure we split the right window here. Let's do a V-split here. And let's just call this spaceship.d. Oops, what did I do here? I misspelled something. Spaceship.d. And again, just to be explicit, this is the module here. And what I'm going to go ahead and do here is take all of my spaceship-related stuff here and put it in here. And then let's go ahead and compile our code. Now I need to import spaceship. Okay. I don't need to put .d or anything. I'm just, you know, bringing in the module. And now I am getting sort of the expected behavior here. What's the expected behavior? I'm getting no property mAccessCode s for this spaceship here. Why? Again, where is it complaining? Again, kind of, you know, looking at main.d at line 10 here. Well, this is private here. Okay. So that's, you know, the reason. Now we have sort of the expected behavior, but, you know, it's not complaining anywhere in here, which is where I might have like some helper functions or, you know, some free functions related to spaceship here. So that's okay here. So again, let's just kind of recap. So design decision here to allow us to put any helper functions related to spaceship in this separate module. Mike is okay with this. Think about, you know, friend in C++. That's kind of the same idea, right? If you can already see the thing, it's fine. You don't have to mess around with friend and so on. It's just one less thing. You just have to know what the defaults are. Now, the question is, how do I set access code? Well, I guess, and let's play around with this. Can I use protected? What does that do here? What if we switch things around here? Nope, protected is still, you know, can't access that. So we got to look at protected still. So this is where I need to write some like setter function here. Void set access code. And I'm going to go ahead and show you that this is going to be public, right? This particular function here. And we'll say mAccessCode equals, I don't know, some value like this here. Here, let's do this. Let's indent this properly here. And let's pass in the, you know, code or something like that. Okay. And let me just kind of mix these around just a little bit here, just to show you the point here. So, and again, stylistically, you might arrange your private and public things together. But what I can do is on a per function granularity, I can actually just put public as well in front of things here. Okay. Okay. So now I can fix this. So I can do s.set access code to, you know, 1, 2, 3, 4. And this, oh, it almost works. I got to import standard stdio here. And this might be one of the things here where, again, we talked about our local imports where it's kind of nice here if I'm only using that in like a helper function or something to just put in there. So anyways, now our code works here, right? We've imported our spaceship module. In fact, we can get rid of standard stdio here. I always try to keep a minimal subset here of things here. But we could create our spaceship set with our, public things that we need to. And then when we need to, we can set up, getter and set our functions and so on as needed here. Okay, so that's public and private. Works basically the same thing for classes and so on. Now let's look at that third one, protected here. And again, it only applies inside of classes or templates that can be mixed in. And again, the symbol can be seen again within the same module, so in that way it's like private. And then any derived class can also see a protected variable here. So let's go ahead and just add in another sort of attribute. I'm going to make this one protected. Let's call it agility here. And this is going to be a float here. And I don't know, by default, this could be 1.0 for our spaceship. And then we need to derive a new class here. Let's go ahead and call it X Fighter, or I don't know, let's call it I don't know, TIE Fighter. TIE Fighter for my Star Wars fans. TIE Fighter, something like that. And we want it to inherit from spaceship because it's a type of spaceship here. And let's see, I can set the well, let's actually see what is publicly, or what is accessible here. Okay, so again, let's just go ahead and do our from our base class spaceship, and then let's go ahead and look at our new derived class here. It's gonna be a type of spaceship. I'm gonna just call it T, which is a new TIE Fighter. Oops, TIE Fighter. I think TIE Fighter is actually capitalized for my Star Wars fans here, but anyways. So I should be able to access speed. Okay, again, I'm inheriting sort of the visibility as well from this class. Equals, I don't know if these guys, they're a little bit more, maybe they're faster by default here. So can I do the M agility here? Can I set it to 9.0F or something? Let's see. Oops, I got to get all my syntax errors correct here. Place that with an S. No property agility for T. Okay, and it's again saying, yeah, defined here. So again, it's available here. So I should have some, attribute here, right? Or field for agility that I can set here. So I should be able to give myself a, let's give ourselves a, set agility, and that's going to be a float. Again, I'm being a little bit lazy here. I'll just call it A here. And M agility equals, A here. Again, just to show you that, I can access this field here. Okay. Oops, let's make sure we include everything here. Oops, and I got to make it void here. Couple mistakes, but we can fix things. Okay, so this works just fine here. All right, now let's see here if I have something private here, like this variable here. And let's go ahead and see if I can call set access code on my derived class here. Okay, so T set access code 1, 2, 3, 4, 5 maybe. Can I do this? Okay, looks like it's okay. So again, that seems pretty fine to me. Let's see if we can print this guy out here with our print spaceship T. Okay, and we are getting the correct access code here, right? It is a type of spaceship, so we can, we've got all the variables and stuff here. Now the thing with private in our derived stuff here, like let's just create some void like helper function here. And again, just to show, like, can I do something with access code here? Well, I guess I can, because it's very visible in the same module here. So in order to do this experiment, we've got to split this yet again here. And let's go ahead and split this and call it TIE Fighter.d. Module TIE Fighter. And let's go ahead and put in our class here. We've got to import it. Import TIE Fighter. And I'm probably going to have to import my spaceship here because I'm deriving from that type here, right? So we need knowledge about it. So let's go ahead and see this one. And now just gives sort of a fuller picture here. It says, yeah, TIE Fighter, undefined identifier, M access code. Yeah, that's private here, right? Let's just verify that. Oops, and let's make sure actually we compile everything together. Just to make sure we're doing everything totally correct. But yeah, can't do that here. If I switch it to public, looks okay. All right. So again, that's the note here. Private here. Note, private fields not inherited. Private stuff, actually. Member functions and fields. Okay? So keep that in mind here. Okay? So that's the idea here with public, private, and protected in this sort of like object-oriented world. And again, as I mentioned, you can have functions and stuff that are like private. Well, let's just give you a tiny preview here just for completeness here. Like, let's say, maybe this helper function here. What if I make it private here? Uh-oh. Yeah, now I can't expose outside of this module here, print spaceship, right? So you can apply these on basically everything here, okay? So that's just a note here. Stylistically, the last thing that I want to talk about here is, I tend to like putting like private colon, and then again with D, the attribute will apply to everything after it. That's a habit I have in C++, but I also see a lot of folks who do this on a per member variable basis in the term of a class here. I also kind of like that. I think that's more of a Java style here. But, it is a little bit more explicit, and, then there's no like confusion, and it gives you a little bit more freedom, I suppose, if you're like wanting to say, hey, this access code, I want to actually group all of my private, variables down here, or all of my member variables. So stylistically, if I'm doing this, I'll try to be better about putting it on a per variable thing. That's just a style thing, so you might have other ideas. I'd actually be curious, because folks always have good input on that here. So I'm going to say here as another note, I sometimes like to put private, public, protected, per member variable / function, so I can refactor. It's just a little bit more clear what's going on here, in my opinion. So, alrighty. So, anyways, today we looked at public, private, and protected. The important notes here, which I'll go ahead and scroll through on this one here, is by default everything is public. So again, that might be a change depending on your programming language that you're in, especially if you're coming from like C++ here. The other thing is that private stuff, same rules as other languages. Protected stuff, basically same rules as other stuff, right? And actually, let's, I don't know if we did the protected variable here. What did we protect here? Agility. So let's go ahead and set M agility equals 5.0, right? We shouldn't get any errors for that. Yeah, no errors, just for our access code. So again, let's go ahead and just put a note here. This is private in spaceship. Okay. So there, now our code is compiling here. So anyways, public, private, and protected kind of work the same way as in other languages. It's just the defaults are a little bit different based off of the D module system. Private visibility is per module. I actually really like that, again, because then I don't have to learn about friends or those types of the friend keyword in C++. And again, you have a little bit more flexibility as to if you want like a whole chunk of stuff to be public, private, or protected, or the same once we learn about export and package. But again, it might be a good idea, or I'm suggesting, or this is something that I'm doing, more in my style, is putting this on a per member variable or per function basis. Again, everything by default is public, but that's also the nice thing that, if you don't use this style here and you just have like small classes where everything's public, it's just very concise code. Anyways, folks, I'll go ahead and leave us off there. I think you get the idea here, and maybe these are some familiar ideas here. And as always, I'll point you to my website here, course.msha.io. You can check out some of the other courses, premium stuff that's not on YouTube. But of course, my D-Language series is here and available if you're following along with these lessons here. So feel free to check that out. Please give it a review if you are. Appreciate that. And otherwise, let me know your feedback on this lesson. Other tips and tricks you know about public, private, protected, maybe rules of thumb that you've come up with that might have been helpful for you if you're using this style of development. Again, one of the reasons I like D is it is just a very fast language to get your code up and running and solve the problem first, and then you can kind of refactor it with hiding the information. Because oftentimes some of the right abstractions are going to be things like using the pimple idiom or these types of things, pointer to implementation, which again I talk a lot about in my C++ series. Those are the important things in my mind about hiding implementation details, more so than the public, private, and protected modifiers. But so you get the code idea right, and then you have this granularity as needed. But anyways, those are just some of my thoughts. Be curious to hear yours in the discussions elsewhere. And with that said, I'll look forward to seeing you folks in the next one.